So, I want everyone to buckle up because in 45 minutes you too will be an expert on this subject. So what is deuterium? Well, let's go to the beginning here. The beginning is the Big Bang. It's the beginning of the universe. And we have the first elements being created, specifically the first element, which is hydrogen, as we all know. Now, everybody can raise their hand because they know what hydrogen is, right? Everybody? Right. Hydrogen is the first element in the periodic table. And deuterium is a version of hydrogen. It's also known as hydrogen 2. But they differ quite a bit. So as the universe formed, deuterium is an element that shouldn't have existed. It's between hydrogen and helium. When the universe cooled, in the first few minutes, it got stuck on its way to being transformed into helium, and here it is. So it's just pretty much we have a same amount of deuterium now as we had at the beginning of the universe. But what is deuterium, really? So as you can see here, we have the first element. Here's the periodic table of elements, and there's so many of them, right? It's up to 103 on this chart. But the very first one is hydrogen. So deuterium is in that part of hydrogen, and it wasn't discovered until the 1930s that hydrogen actually had different isotopes. An isotope is a version of an element. And hydrogen has 3, the second being deuterium, third being tritium, which we don't really talk about because it just doesn't occur too much. So the difference between protium, which is the regular hydrogen, and deuterium is that deuterium has an extra neutron. The abundant form of hydrogen, which consists of 99.8% of all the hydrogen in the universe, is in this protium state. And this protium hydrogen is the hydrogen that we use for our biology. It's the most, not only the most abundant element in the universe, but it is also the one that is used to produce the energy in our body, produce the energy in stars, produce the energy in rocket ships, etc. So this form of deuterium, this form of hydrogen known as deuterium, differs in that it has 1 extra neutron. What this does is it increases the mass. It doubles the mass of the hydrogen. Why this is so important, you'll find out as we go along. So you can see here how in the beginning you had 1 proton, and then as the evolution into the periodic chart occurred, you have deuterium, and then from that other elements are formed. So we're just stuck with it here in our world, and our planet has a certain amount of deuterium, and so do our bodies, and I'm going to explain why this is bad for us and what we can do about it. So hydrogen, as we know, is 1 component of water. When we take 2 hydrogens and 1 oxygen, we get H2O. And when we replace that hydrogen with 1 deuterium, we get something called HDO. And then when we have 2 deuterium, we have what's known as D2O, which is called heavy water. What we're going to talk about today is semi-heavy water, or this HDO, because it occurs naturally in all the water on Earth. Roughly 1 molecule in 3,300 molecules of water is this version of water known as HDO. So not all water is H2O. It has many isotope combinations in it. And specifically, we'll focus on this one known as HDO, or semi-heavy water. So you can see that all water on the planet contains this in a very small amount. So if you take a liter of water, you'll have about 6 drops of semi-heavy water in a liter of water. Doesn't seem like a big deal, but I'll explain to you why it is in a moment. So on our water planet, we actually don't have that much water that's in a potable state. That's drinking water. As you can see, only 2.5, maybe 2.75% of the fresh water on the planet is drinking water, and most of that is frozen. So only 1% of the water on the planet is really available for us to drink. And this water is roughly, in the oceans are 155 parts per million of this HDO, or deuterium. And drinking water varies between 145 to 155 parts per million. So whatever water you drink wherever you are, you're going to be introducing deuterium into your body, and that includes for the food you eat as well. So this is different around the planet. You can see on this chart, you can see where there's places where you have less deuterium on the planet, like Antarctica, and so some places you'll have less, and some places you'll have the average, which is 150. Now, how does this play out in our bodies? Well, what produces water in the bodies is the mitochondria. Mitochondria is the powerhouse of the cell, as this slide will tell you. Roses are red, I wish you well, and you have to finish that. Mitochondria is the powerhouse of the cell. We learned this in school, at least I hope we did. And mitochondria produces the energy in our bodies. So mitochondria, out of the 35 trillion cells that we have millions of mitochondria. We have thousands of mitochondria in our cells. And this is what really determines how much energy we have, because mitochondria produces ATP, adenosine triphosphate, which is the energy currency of our biology. So we actually make double our body weight in ATP per day, if you can believe that, because it's a constant recycling process. So the function of mitochondria is to produce something known as metabolic water and ATP energy. And we'll talk about this metabolic water. The metabolic water is very interesting because the water inside your deepest nano-confined spaces within the mitochondria is not any of the water you drink. In fact, the water that makes up the cells in your body is water that you synthesized from hydrogen and oxygen. It's not water that you consumed, just like grandma's apple pie. It's homemade. So we recycle, if you can believe it or not, 1,500 gallons of water per day, metabolic water per day. So we are truly water beings. And this is because 1.45 million years ago, eukaryotes, which were the first cells, not the first cells on the planet, but the first cells to use oxygen as a means of, as a strategy for life, made a deal with these other organelles. We don't know where they come from, and these organelles are mitochondria. And the deal they made was that the eukaryotes, the cell would provide the energy and the protection for the mitochondria, and the mitochondria will provide the metabolic water and later provide the energy. And this deal has been in place for 1.45 million years, rather successfully actually. So you can see it's a very complex system, and the complex system involves shuttling protons, which are taken from food. So food breaks down into essentially its basic components, and what you want is the protons. And the protons shuttle through this electron transport chain and do all kinds of things. We can get into the biochemistry of it, we don't have time. But first and foremost, the cell protects the mitochondria makes the energy. And this leads to the recycling process of ATP to ADP, which again is the energy currency of our biology. So it's very interesting because we have two sets of DNA. We have our mitochondrial DNA and our nuclear DNA. And it's like we are made up of two separate beings here. So, and the main being that we talk about here is the mitochondria. Mitochondria, as you can see in this illustration, is made up of electron transport chain, Krebs cycle. Essentially, what I want to get to is these little motors that sit at the end of the electron transport chain. And this is really important because these little motors is what creates the ATP in our bodies. And these little motors spin at up to 9,000 RPM, and they shuttle protons, and as they spin, they produce this adenosine triphosphate. From ADP becomes ATP. And you can see these little motors. These little motors make a great case for intelligent design because there's really no way that something like this could have occurred naturally. It's like if you put a piece of aluminum in your front lawn and ask how long will it take for this to evolve into an internal combustion engine. It's going to need some intelligent input in order to happen. So here you have these ATP synthase nanomotors, and they work specifically on protons from hydrogen. But every 5 seconds, what happens is they get impinged upon. They get a deuteron, which is a proton-neutron pair from the deuterium that's abundant on our planet. And what does this do? It causes these motors to stutter and break down. So they shake and they stutter. So every human from birth to death is compromised in their mitochondrial energy production by the ubiquitous presence of deuterium. Once the deuterium in water enters the cell and becomes accessible to energy-generating mitochondria, it functions as an isotopic toxin that is ultimately fatal to the inner mechanisms of the electron transport chain. This is new information that's 60 years in the making. So this is a very, very big Trojan horse for our cells, and we're living in this time where we can do something about it, so that's fantastic. But where did this discovery come from? Well, that's interesting too, because in the 1950s, there was a couple populations of people in the Soviet Union, in Siberia actually, and these were primarily Eskimo-type people. They looked like this. And they were trying to figure out why these people had so many of their population over 100, why they had so many centenarians. And you can see over here that it was, let's see, that's right, there was 324 centenarians per 1 million, which was 6 times more than national average. And they were trying to figure out why these people were so long-lived and so healthy, living in such a harsh environment. And after a number of years, they figured it out because they tested everything. They looked at their diet, looked at their lifestyle, and they looked in the water that they drank. And they saw that their water, this glacial water that they were consuming, was 16% reduced in deuterium. So this started a whole field of study, and eventually it led to what we now know as the branch of biochemistry known as deuteronomics, which endeavors to explain how deuterium is measured in our bodies. So this research first started in the late 50s. It was published in 1960 in the former Soviet Union, and the studies were done on what happens when you take a biological organism and reduce the amount of deuterium in the body, and the opposite, what happens when you increase the deuterium. So here's an interesting study, or interesting literature I found from Russia, from the census, and it showed that 1819 census of Russian population, that they had 1,789 centenarians, and 2 of these people were 160 years of age. Now, we don't know if this is true, but these people live in these areas where they're consuming water and food grown in a deuterium-depleted environment. And here in the United States, they also were clued in on this, and they published also in the early 1960s, 61 or 63, I believe. And the conclusion was that deuterium is incompatible with survival. This is the conclusion they reached in the early 60s. So it's taken this long to get to a point where we could actually do something about it. So the timeline is very short. This is very new information. It's very exciting because deuterium wasn't discovered until 1931, that hydrogen had different forms. And then as time went along, you had different scientists publishing their findings on deuterium and how it affects our biology. And in 1999, there was actually the first conference on deuterium and how it affects our biology. And then something happened in 2007 that was quite amazing, is that it was shown exactly how deuterium damages the mitochondria, and this is the ATP synthase nanomotor that I showed a couple minutes before. So a doctor, professor, dean of pharmacology in Turkey actually wrote a very pivotal paper, the biological effects of deuteronation, ATP synthase as an example, and he actually showed that what we have in our biology is a mechanical problem, and this mechanical problem goes back to this ATP synthase nanomotor when you have, instead of those protons coming in, which are right there, imagine that being twice the size. So it's like putting a square peg in a round hole. It doesn't fit, causing this to stutter. So 6 drops of heavy water in every liter of water. Doesn't seem like very much, obviously, and this is why you look in Wikipedia, look up deuterium, and it says it has no harmful effect, but I beg to differ with you. When you look into the blood, you see that there's 3 to 5 times more deuterium in our blood than the main constituents that we need for survival: calcium, magnesium, glucose, potassium, etc. So there's quite a bit of it. There's actually about 1.1 grams of deuterium in the human body, all the way up to 5 grams some people have, which is extremely a lot for something that does this kind of damage. Considering only 0.0125% of all hydrogen in the body is deuterium, this is quite a significant finding that there's so much dispersed among all the hydrogen that's in our bodies. So, like I said, 1.1 grams of deuterium, and this is a cumulative. As we age, we get more deuterium from the food and water and beverages that we consume 24 hours a day. So when they looked at the consequences of heavy water or semi-heavy water, they saw that if you were to give to somebody 35% heavy water, which doesn't occur in nature, that has to be made in a lab. However, what happens, especially in higher animals and in mammals, is by the 3rd to 5th day, the animals die. So deuterium is not compatible with our metabolic process. Inversely, we have the depletion of deuterium shows the complete opposite. It shows that when you deplete deuterium, you have an incredible biological benefit to your metabolism, because you're not impinging that nanomotor that's working so hard to make ATP for you 24/7, 365 for your entire life. So if you could reduce the amount of deuterium in your body, in your water, in your food, then you have less damage that occurs to these ATP synthase nanomotors. Otherwise, you have about 1,500 to 10,000 deuterium disruptions every second that happen in your body. So this is Dr. Ogun. One day he'll win the Nobel Prize for this work, but it's so new. And he's the one that discovered how deuterium affects our mitochondria. And again, here I illustrate for you. There's the bad guy right there. So every 5 seconds, if you can imagine, you get one of these go through your motors. It's like being kissed in the morning by your significant other, and then every once in a while you get an elbow to the face. This is what's ongoing in our bodies nonstop. So what we want to do is we want to slow down our aging process. And the way we slow down our aging process and save our mitochondria is to limit the amount of deuterium that we put in our bodies and flush some out that we already have. This is from Dr. Ogun's paper. You could see that he came to the conclusion that there's a stutter and a shaking that happens within the mechanism of the ATP synthase nanomotors. And I encourage everyone to read up on these ATP synthase nanomotors, because this is something that is nanoscopic in our biology. These motors are producing all our energy, and they run better than any internal combustion engine or any motor that we could create ourselves. And this is pure nature. So here's some more illustrations of the ATP synthase nanomotor, just to whet your appetite about learning about this feature of our biology. And all biology, really, anything that uses oxygen is going to have this ATP synthase nanomotor. And they rotate at 3 to 9,000 RPM at 100% perfect energy efficiency, something we can't make yet ourselves. And if we didn't have that, we wouldn't be here. So this deuterium-hydrogen ratio is very critical in our bodies. Here's some more illustrations of the ATP synthase nanomotor. I wanted to illustrate for you how much it resembles an actual motor and how it actually works like a motor generator. And the thing that keeps them from working is this ubiquitous amount of deuterium in our environment. So deuterium is kind of like an elephant in a china shop. It just doesn't belong. It's too big. It interferes with our biology. And I'm going to go into a few other ways it interferes with us other than inside the mitochondria. The mitochondria is the most important way that we get damaged by deuterium. And as you can see with this little illustration, deuterated stuttering of ATP synthase nanomotors over time. And the more stuttering, the more shaking, the more deuterium, the less ATP production over time. And this is one of the reasons why we age. So this is an incredible biological discovery. And you could see that mitochondria, healthy mitochondria is everything, and unhealthy mitochondria is the opposite. It will cause us to rapidly age, decay, and die, atrophy and die. And cells die by two ways, necrosis and apoptosis. So when you have too much deuterium in your bodies, eventually the mitochondria break down, which leads to cell suicide, apoptosis. And this happens through a process called blebbing. And it basically, what happens when you have these motors operating and they stutter and shake, it causes the membranes that's holding them to shake loose, and then you have leakage. And once you have leakage in through your membranes, then all bets are off, and no energy can be produced. Because in order for energy to be produced, you have to have a differential of a lot of protons here, no protons here. So they want to shuttle down this pathway. And if there is some damage to it, then you have bleed through, and you have cracks in the membrane, and then you have this proton leakage, and this ultimately leads to what's known as apoptosis, or first senescence in the cell, which is a kind of a stasis, and the cell says, okay, am I going to be able to fix this? And eventually says, no, I can't fix this. So it goes into cell death and apoptosis. And this is very bad because it affects other cells. So as we age, when you're young, you have thousands and thousands of mitochondria in one cell, maybe when you're 10 years old. And by the time you're 70, you maybe have 10% of that. So you can see that maybe the mind is willing, but the body is weak as we age because we just don't have the energy. And it's all really just age is really just defined a lot by how much metabolic energy we have, and that's defined by how much mitochondria we have. So again, to review, you have a proton and electron, which runs everything, and you have a proton, neutron, electron, which is deuterium, which destroys everything because of that bad neutron. And so deuterium, being the first and most abundant naturally occurring toxin harmful to life, nature's strategy is to get it out. So we have complex processes in our body because this is almost 1.5 billion years of evolution to figure this thing out, to figure out how to limit the amount of deuterium in our bodies. But the amount of deuterium on the planet has been rising, so our bodies suffer from that. Ideally, we have about 125 ppm deuterium in our bodies, but most people have about 150 now. So herein lies the problem. And I'm going to illustrate some other ways deuterium damages us as if the mitochondrial one wasn't bad enough. So here's an illustration of a HDO molecule, or HOD. You can see the bond is shorter. So when the bond is shorter, you have, it's harder for that bond to break. So this can be explained through something known as quantum tunneling. Now, when we think of quantum tunneling, we think of something like this, right? Because nobody knows really what quantum tunneling is. Well, I'll explain it. So here's a much simpler way to understand quantum tunneling. Okay, I'm just kidding. You can't understand that. But that's essentially what's happening. So in quantum tunneling, classical physics tells us that elements have to go over a hill to get somewhere. So, but hydrogen says, I don't have time. I don't have time to go over the mountain because I have so much work to do. I have so much energy to produce. I'm busy, 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 busy. So what it does is it goes through the mountain, it goes over the hill, and we can't explain why. And hydrogen, we can't slow it down enough to ask. So we have this unique feature of our biology where we break the laws of physics in order to live. Everything that uses oxygen on the planet, every cell that uses oxygen breaks the law of physics in order to survive, which is, to me, when I learned that, it's just incredibly profound. Because at this nano level of biology, all bets are off. So we will break every rule we can, and we do, in order to survive. And deuterium just does not quantum tunnel the same. It barely quantum tunnels at all. In fact, no other element quantum tunnels, only subatomic particles all the way up to hydrogen. And this translates to a carbon-deuterium bond dissociates 9 times slower than a carbon-hydrogen or carbon-protium bond. So what does deuterium do? It slows us down, like gum on the bottom of your shoe. It's a nice shoe, you're ready for the race, everything is great, but then you step into something like this. So that's a problem, right? That's a problem. So you want to be at a high vibrational energy, and the more deuterium you have, you go into a lower vibrational energy. And where this is most reflected is in the mitochondria, because the mitochondria is the ultimate expression of our biology's way to create energy and keep us alive. So where do you see the most amount of mitochondria? Mitochondria are producing our energy. It's kind of very interesting to look at in the body where the mitochondria is concentrated. And where there's the most mitochondria is right here in the human eye. Now, this is the highest evolutionary expression of that symbiotic deal that was struck between 2 primitive cells 1.5 billion years ago. So it's our most complex sensory organ. It's really mitochondria's magnum opus is the eyeball. It's a part of the central organized nervous system. It's a silver screen projecting the motion pictures of your temporal experience. And when you look at the eyeball or the retina in the eyeball, it has the most mitochondria. And what does this mean? Well, what does it translate to? Well, it translates to your reaction time, how fast you process thought into action. And so when I measured myself recently, I noticed that I have the reaction time of a 19-year-old, and I'm 50. Why? Because my mitochondria are healthy. Why are my mitochondria healthy? Because I have less deuterium in my body. So, quick review. Deuterium damages the ATP synthase nanomotors that produce ATP. Deuterium affects the electron transport chain comprising oxygen carrying capacity. Deuterium mechanically distorts DNA and enzyme molecules, causing errors in transcription. Reduced bioenergetics promotes an accumulation of DNA errors, cellular mutation, and aging. So we haven't talked about how it damages DNA yet. But you can see DNA made up primarily of hydrogen molecules in different configurations would really suffer if those hydrogen are replaced by deuterium because it's twice the mass. So it would distort the shape of those DNA molecules. And if you have too much deuterium, it distorts the shape enough that you have errors in transcription and replication, which causes mutations, which causes us to age, so forth and so on. And you can see that even at very low levels, deuterium can slow down DNA replication processes or otherwise interfere with the repair of DNA damaged by solar radiation. This is one study that was done there. Probably in the studies are are up in the hundreds now about deuterium over the last 60 years. So a simple graph shows that accumulation of DNA errors as we age, and I postulate that this is mostly being caused by deuterium. So when we start out in life, we start out as a hydrogen-fueled supercharged drag racer, and at the end we have a kind of slow crawl to oblivion. And the way you fix that is by consuming water that is purer. That is, and when we mean pure, it's more H2O and less HDO. So that translates as this equation here, which means 6 times proton motive force. This is when you reduce the deuterium in your body, you have the potential to increase your energy in the mitochondria in the electron transport chain by 6 times. Now, it's never going to be 6 times. That's a theoretical limit. But wouldn't it be amazing if your energy was increased double or even triple? That's a big success right there. So proton motive force is the name of the game. And that happens, that increases when you reduce the amount of deuterium in your drinking water specifically. And let's look at one other way that deuterium causes us to age, and that is our collagen. Now, collagen, like most things in our body, is made up of coils. If you look down at if you look at the double helix spiral of our DNA and you work out from there, everything is kind of like that. Everything's like a spiral coil within a coil within a coil. And so is collagen. So you have these collagen fibers in the body, and as we age, they get you know, your face changes. You start getting less collagen, less elastin, which manifests as a physical sign of aging. So if we can increase or decrease the amount of deuterium, increase the integrity of our collagen by decreased deuterium, you have something known as youth, or longer youth. And here's a study that was done in China which actually shows that. It shows topically that when they used deuterium-depleted water, you could see how much collagen buildup they had versus normal amount of water. So the other way deuterium damages our body, as if the ones I talked about so far weren't enough, is enzymes. Now, we have some enzymes in our bodies that they're stereoisomers, and what that means, they need to be perfectly mirrored pairs in order to function properly, and this is known as chirality, or chirality. I don't know how you pronounce that honestly. So, is it? Chirality? Yeah, I said it right the first time. So, in 1974, a scientist at a physics conference proposed this. He says, well, you know, what if you have one side that's heavier than the other? Well, you're going to have errors in replication and transcription. And this is the illustration that I like to use, the example I like to use is the airplane. So an airplane has to flies because it has these wings that are symmetrical, and they're the same weight, size, and everything. And this gives you perfect symmetry, so it allows you to fly. But what if one wing was slightly heavier than the other? You'd have a lot of problems, wouldn't you? And this is what's happening in our enzymes in our body with deuterium. So here's an interesting example of somebody that is very long-lived. This is a Bagua master, and here he's pictured at 118 years old. There's actually a really great video of him on YouTube. And Bagua is a martial arts discipline, form of Tai Chi that uses a lot of spiral movement. So as I was saying, how everything is a spiral within a spiral, a coil within a coil. And here's a little clue. This guy practiced something all his life and was able to live to 119 years old. And if you look at him move at 118, it just blows your mind how well this person moves in what we consider a unreachable age for most. In fact, if you were to look at longevity and you have a 100-year-old, a centenarian, and do you know the chances of that centenarian reaching the age of 110? Well, it's 1 out of 900. Only 1 out of 900 people that reached age of 100 reached to 110. So at the end, it's a very quick unwinding of your mortal coil. But through this spiraling or constantly winding up in spiral movements in our bodies and whatever practices we do, this could ensure that we have a longer lifespan. So deuterium, as I said before, has increased on our planet. And this is the problem, because just to give it to you really straight, in our bodies, in order for them to function really well and optimally, we need 125 ppm of deuterium in our bodies, or less. And I could guarantee everybody here in this room, if you're not consuming deuterium-depleted water, is going to be at 150. And this is because something happened. Something happened, who knows when, 10,000, 100,000 years ago. But what happened was it increased the deuterium on our planet. So the lowest deuterium you're going to find is right here in Antarctica. It has 89 parts per million, because this is part of Antarctica this is a part of our planet that was kind of locked in. It showed what water was like 180 million years ago. An event occurred that caused all this water to freeze and remain the way it was 80 million years ago, when it looked like this, and you had giant animals, giant plants, which I postulate, my hypothesis is that because there was less deuterium. A couple other things too, but we don't have time to get into that. So, and even in the Bible, you could see that the long life of the patriarchs, if you were to believe it, was dramatically shortened after this event known as the flood. So the flood, whatever the flood was, introduced an enormous amount of deuterium in our bodies. Here's a cute illustration of an average beaver today and a pre-flood beaver. It's like 4 times the size, and potentially same thing even with humans, because many scientists outside the current established dogma believe that humans were at one time much larger than they are now. And if you look at the largest mammal on the planet, which is the blue whale, well, what does it do? It consumes deuterium-depleted water from Antarctica because of that glacial runoff. And there's other great examples of this, but another example I like is this mega penguin that lived in Antarctica at the time that some cataclysm occurred, freezing all that water. And so if you were to consume 89 ppm water for many, many generations, maybe we would regain our stature and our size that we once had, if that is to be believed. But nevertheless, Earth's water is heavy, and this is a big deal, because now that we know this, we can do something about it to increase our lifespan, to decrease the damage that constantly occurs from this rare but formidable, widespread isotope of hydrogen. So this little known secret does change lives if you follow the science. And so this science is going to really help us as we journey onto the stars. Not only is it going to help us here on our planet, but I wrote an article that you can read that makes a really great case for why we need deuterium-depleted water in outer space, because of the increased amount of damage that we're exposed to up there. In fact, if we go to Mars, there's 7 times more deuterium there when we start making water, and we're going to realize that we're not going to live very long. So this is a big evolutionary leap that we are in the midst of. And it's all about water. So in the Himalayas, it's one of those places where you have reduced deuterium. You have about 125 to 130 parts per million. And this explains why there's people that live there, the Sherpas, that can climb Mount Everest without any supplemental oxygen. When you have less deuterium in your body, you can utilize oxygen much better. And so in addition to drinking deuterium-depleted water to lower your deuterium, there's other things you can do, and that is a keto-adapted lifestyle or a ketogenic diet, because for every 2.4 pounds of fat burned, 1 liter of deuterium-depleted water is produced. Nature's strategy is to deplete the fats and to load the carbs when it comes to deuterium. And of course, you produce a lot more ATP when you're running on fat. So what we want to do is increase proton motive force to decrease the deuterium in our bodies. And we do this by drinking deuterium-depleted water and focusing on a more keto-adapted lifestyle. So now we're going to talk about our little startup, which is Litewater Scientific, because we've endeavored to solve this problem not only for us, but for ourselves. So our little startup, Litewater Scientific, has been 20 years in the making. And because it's very hard to separate water, from HDO from H2O. It's not a simple filtration process. It's not something that you can do through reverse osmosis or standard forms of distillation or filtration. So this is a very difficult puzzle to figure out, very difficult nut to crack. But it was done, and over many decades. And so what we did is we just studied the hydrological cycle, because in certain parts of the planet, as I said before, there are waters that have less deuterium, and it's because of the hydrological cycle and how it works. I don't have time to get into it. However, this is what our production prototype looked like, and now our modern commercial production. Vacuum-assisted rectification distillation is the name of the technology that we use, and there's only a few factories in the world that are able to do this right now. But what we have discovered and what we're offering is a new standard in water purity. And eventually this standard will be taken up by everybody. It will be accepted, but right now it's just being introduced to the world. So this is myself in our factory, and to quote Isaac Newton, if I've been able to see farther, it is because I stand on the shoulders of giants. So it took an enormous amount of engineering effort from dozens of scientists, engineers, inventors, fabricators, etc., to create this plant that we have that produces deuterium-depleted water, and this is what we sell. We sell DDW, known as Litewater. And the reason we call it Litewater is because physically it is lighter. If you put it on a scale, put a liter of water on a scale, ours will weigh about 300 milligrams less, because it has 95% to 97% of the deuterium reduced. So this is an answer. This is what I like to think of as the crown jewel of biohacking, is the reduction of deuterium. Very different than other interventions, because you're not putting anything in your body. It's really about taking something out or reducing it. So what we've done is we've made a water that is 10 parts per million and 5 parts per million, which is quite a difference to 150 parts per million, 94 to 97% reduced. But what you do is you follow a special protocol, and this protocol calls for dilution. So you dilute this super deuterium depleted water that we produce with regular water to get a lower deuterium water, somewhere between 80 parts per million and 120 parts per million. And over time, you drink this and you dilute or reduce the amount of deuterium in your body through the process known as hydrogen exchange. When you consume deuterium depleted water, you will remove some of the deuterated or deuterium rich water in your body. So over time, 3 months, I'd say, you will reduce down to 120 ppm or lower, depending on the protocol that you use. And if you do it as a cumulative effort, over time you will see incredible change in your biology, not because of the water, but because your body is now lower in deuterium. So you have more metabolic energy. You have less damage to your mitochondria, your DNA, your enzymes, so forth, and so on. Now you can also test for this deuterium in your body. We have a lab that we set up and test your saliva. And so you can see, you can get your baseline, and then you can test after 3 months of being on a deuterium depletion protocol and see where you land. And also test periodically for maintenance. Now, many studies have been done on deuterium depleted water. My colleagues have worked very hard over 20 years to do a number of studies, not only creating a process for removing deuterium, but also proving its efficacy. So I won't get into all the studies now, there's just really no time, but one of my favorites is this one right here. that shows that after 30 days of consuming deuterium-depleted water, in effect reducing the deuterium in your body needs half the amount of oxygen to perform the same amount of work. This is incredible. This shows proton motive force in action. And this is the reason why these Sherpas in the Himalayas can go to and summit Mount Everest. Their acclimation essentially is because they're deuterium depleted somewhat by 15 to 20%. So this gives their oxygen processing ability a big, big boost. So what do we have here? Do we have a fountain of youth? Something like that. We do. We have a practical fountain of youth in a sense, if you believe the information presented. So I think this is something humanity has been waiting for, not only the awareness of this problem, but a viable solution of its mitigation. And the potential implications are a good analogy to drinking of the waters of immortality, because mitochondria is immortal as it is passed down as long as there's aerobic life on the planet. It only needs energy and the limitation of deuterium from entering it, and more protium, more protons, less deuterons. So practically, what does that look like? Well, we really don't want to get to become this guy or even that guy. We want to stay right here our entire lives, fully optimal for 100+ years. And the way you get there is to reduce the deuterium in your body. That's one of the main things. I think that is the upstream solution to all the downstream problems that we have. I think it's one of the best interventions that we could do, and it's a true biohack, because this is using the best of science and the best of technology to achieve a functional goal. So this has been overlooked for a long time, but it won't be overlooked now. This is why I'm up here. This is why I'm sharing this information with you. So the name of the game is geroprotection, and what we have as the #1 geroprotector is deuterium depletion. So deuterium depletion may be the most important health and medical discovery of our time. Only time will tell. So it is truly going to be quite something in the 21st century. We're going to make some evolutionary leaps, and this is one of those evolutionary leaps to increase our level of awareness, longer life, deuterium depleted body, and this will really strengthen us for the future that we need in this complex world that we've created over the last 100 years. So this is a viable solution, and I encourage you to study more up on it and see what you can do to lower the deuterium levels in your body. And thank you so much.